Assalamualaikum and good morning. So I'm Amirhilmi bin Hassan. My metric number is 196264. So today I'm going to present about application of complex function, which my topic that I select on engineering mathematics 3. So I'm going to present about application of complex function. So about application of the complex function, which is the function of z that has a real part and also the imaginary part, which is x is the real part and y is the imaginary part. So the application of complex function that I select is about contour integration, meaning the meaning is about the integral of a complex function along a closed path doesn't depend on the path itself, but on certain values, meaning that it has a residues and also zeros and also the singularities. And the application that I choose is electrical engineer, which is electrical. They have learned about the electrical circuits with alternating current. One of the first places engineers see complex circuits, meaning that they about the contour integration. This is the figure that about the contour integration that applied in electrical engineers. So as you can see, this is the graph, like circle graph, and normally electrical engineers is used for the generating function in a Z transform. So as you can see, this is the contour integration that they have managed to do. So complex function is a complex variable that simple solution that have been used in real life. So that's all from me. Thank you.
Hello and a good day. So today I'm going to present about applications of vector calculus. My name is Kiran and my matrix number is 197810. Though vectors sound complicated, it's basically directions, right? If we were to talk about vector. So vector is basically used in navigation by air and navigation by boat. So navigation by air, we know that aeroplanes, they need proper data so that they can manage their speed and their angles of turning and all, so that they can land properly and have a safe flight path. This is basically because of the vectors that are used in their programming during their flight path. And also navigation by boat, it's basically the same, but the thing is it's on water and they use the nautical miles and also different type of vectors so that the boat has a safe path in water. And then we have three other things, two of which are physics, right, related to physics, fluid mechanics and also electrodynamics, and lastly computer programming and graphics. So it is mostly on graphics because graphics requires vectors on, let's say we want to make an animation which is walking or running, so we need vector data on how fast the animation has to go and in which direction it has to go, so we need to make calculations. So this is where vector calculus comes in, according to my understanding. Thank you and have a good day.
Assalamualaikum and hi, my name is Muhammad Muzaffar and my metric number is 196044. Today I would like to present the application of Fourier transform, which is signal processing. When we are editing the video, we always heard the unwanted sound. So with this signal processing system, as you can see, there is a two wave here, the red wave and the blue wave. When the sum of these two waves will get the two sum of the corresponding. While we are doing this signal processing, you can see that we can delete the unwanted sound, the unwanted video, using this corresponding. So the red wave, the unwanted, will be gone. Only the two waves that we want to hear for the audio. So that's all from me. Thank you.
Hi, hello, my name is Emir and the magic number is 182016. I'll be presenting a Fourier series. So as you can see from the picture that this is called a square wave. The square wave is to complete every cycle of every 2 pi seconds. So to present the period, right, it's t is equal to 2 pi second per cycle, and also the frequency is 1 over 2 pi cycle per second. Also can represent by hertz. So we can take the period function like this and represent it as infinite sum of sine and cosine of different frequencies. To clarify that, we can use the equations of and write it as sine and cosine. So for the function ft, the first one will be represented by a sub 0, and it is the baseline constants to show that whether the graph shifts up or down. Why start with cosine? It is because it will be logical if it can involve period of pi and 2 pi. If cosine is much more weight than sine, we know that cosine is much heavier, which means a lot more cosine than sine. So we just add the a sub 2 cosine to t to weight the frequency, to weight the coefficient of frequency. So a cosine t can represent equals to 1 over 2 pi, and a 2 cosine 2t can represent 1 over 2 pi, which means it's twice the frequency as the 1 cos t, a 1 cos t. Also the same for b sine t, b2 sine 2t, and also b3 sine 3t. This concept is the same. So this equation or this function is explored by Fourier itself. It is to study the differential equation. Differential equation is easy to solve when involves sine or cosine. It is not so easy to solve when you have more general function. This application is used by electrical engineers. It is to measure how much of different frequencies that this function contains. For example, right, you see the graph and it shows that A1 is much more than A2, which means that a lot more 1 over 2 pi in the graph rather than 1 over pi frequency. So this process helps in signal processing. Okay, thank you and have a nice day.